Recording now. Example 9 from page 309 says that a skateboard ramp requires a rise of 1 foot for every 3 feet of horizontal length. I'm just going to call that the run. So we have to find the length of side B and side C, and we have to find theta. Now they told us what the rise is, didn't they? What's the rise?
1 foot.
1 foot. What's the run? 3 feet. 3 feet. So let me write that as a ratio. The rise over the run. And you guys just said the rise is 1 and the run is 3, right? Now let's take a look at the ramp. I drew the ramp here.
So B is equal to 3 now.
Well, isn't the rise of this ramp 4? So let me put a 4 here. And the run, we don't know, it's B. So we're going to put the B here. I'm going to use a different color. But that will be B that we need to find. So my question is, how do we solve a simple equation like this?
So you multiply the bottom by 4. Since that's what you did on top. Right?
No, not by 4. Well, yeah, you could say that. We can multiply both sides by 1/4. You could say it that way. Or we could cross multiply. Can't we cross multiply here?
Mm-hmm.
Okay. Or multiply the means and the extremes. B times 1 is what? B. 3 times 4 is what? 12. So B is 12. So let's put that here. B is 12. Now that we have 2 sides of the triangle, we could use a trigonometric ratio, trigonometric function. And we need to find this angle. Let's call this our working angle. And let's take a look at which sides, the 2 that we have labeled, or that we have numbers. Let's see which of the 3 they are, opposite, adjacent, and hypotenuse. Which one is this? Opposite, adjacent, or hypotenuse, the B? Adjacent. Let's put that here. And what about the rise, this length here? Is this opposite or hypotenuse? Good. It's the opposite. And of course, this is the hypotenuse then, right?
Yep.
But let's just look at the 2 that I circled now. We have numbers there. We have 4 and 12. We have the opposite and the adjacent. Which trig ratio can we use when we have the opposite and the adjacent? The tangent. So let's write that if I have room. That the tangent, what's our angle, everybody?
Theta.
The tangent of theta is the opposite over the adjacent. Do I still have room to go down there at the bottom? I think so, yes. So the tangent of theta, what should we put for opposite?
1, 4.
How about 4? And for adjacent? Can we reduce that in our head?
Yeah.
1 over 3? Let me just put 4 over 12 and then equals 1 over 3, okay? Okay. So now we're going to write this as an inverse function. So our input, our input now won't be theta, it will be what? 1/3. When we do that on our calculator, it'll be 0.3 repeating. And our function won't be the tangent, but what's the inverse of tangent called?
Opposite.
It's called inverse tangent. Some people call it arctangent. And we're going to punch that into our calculator. The inverse tangent of 1/3. I don't know what that is, but everybody get out your calculators.
18.4.
I think you're right. I haven't done it yet, but let me do it. And inverse tangent, I believe that's right. Yeah, about 18 point, can we call it 435?
Yeah.
Okay. 18.435 degrees. And let me write that here. Theta equals 18. Can we see that? 0.435 degrees. We could call it 444 if we want. 18.44 degrees. Okay? 18.44 degrees. That over just a little bit. Oh, so we've got 2 of the things we wanted so far. We wanted to find B we wanted to find C, and we needed to find, we just found theta. So that's 18.44 degrees. B was 12 feet actually. Can I write that little mark for feet? Okay. So the other thing we don't have right now is C. There's a couple of ways that we could find C. We could use Pythagorean theorem, and that would probably be most accurate. Does anybody remember what the Pythagorean theorem is? I hope.
Not really.
A squared plus B squared is C squared. And by the way, we don't have to use those three letters. Can we use A and O? Okay. So that'll be what squared? 12 squared plus 4 squared is equal to C squared. What's 12 squared?
44.
Plus 16 equals C squared. And what's that give us?
160.
160, if I have room. So 160 equals C squared. So how do we find C? C is the square root of 160. Yeah, we can, you're right, we can estimate it, but we can also simplify that. So let's write that up here. Isn't that equal to the square root, if I have room, isn't that equal to the square root of 16 times the square root of 10? 160? What's the square root of 16? 4. So C is equal to 4 root 10, to be exact. Now, we could also, let me type that in here, or let me write that in here, 4 root 10. We could also find that, I'm going to highlight it, and let me write it also here over in our, that didn't smear a little bit too much. 4 root 10. So that's the exact answer. But what I also want you guys to do is punch that into your calculator. Punch in the square root of 10 and multiply it by 4. So we can get a decimal value. Isn't it about 12.65 approximately?
Yeah.
Let me write that here. Approximately, did it show up on the edge here? 12.65? Okay.
12.6.
Yeah, if you rounded it to 12.6 or 12.7, I'm not gonna, or 12.6, I'm not gonna mark any points off. But I want you all to see, like I've always said, that there's usually more than one way to do a problem. Let me shrink this a little bit. Is that better? No, let me shrink it a little bit more. Oh, it won't shrink when I'm recording. I just remembered. But anyway, the other way to do this is, isn't this the hypotenuse and 4 is our opposite?
Yeah.
Which ratio could we use for opposite and hypotenuse? The sine. So we could say that the sine of 18.44, now remember we rounded this a little bit, so our answer will be off a bit, a small bit. And the closer we make this, the closer our answer will be. But we could have written, and I think I have room right here, we could have said that the sine, remember the opposite and hypotenuse, the sine of 18.44 is equal to the opposite, which is 4 over the hypotenuse, which, let's say we don't know it, 4 over c. And this is over 1. So if we cross multiplied here, first we'd have to calculate the sine of this, and then cross multiplied, we'd get about the same thing. Okay. I don't think I have room to write any more on here, so I'm going to go ahead and stop it now. And then I'm going to do it after I